Yes. So welcome guys, welcome back to my channel Physics with Atul Sir. So guys, today we are going to tackle the most important numericals from current electricity guys by solving one question, one circuit question guys. We are going to solve all the difficult parts of exercise 8b numerical, especially of EMF, of terminal voltage, of voltage drop and potential difference numericals. So what happens, students find very difficult to tackle such questions. So what I have done, I have made one questions such that it becomes easy for you to find everything that they are going to ask you in exams. So they will ask you any one or two or three things from these questions they have given using this circuit. Okay. So again, let's give a quick solution for this numerical guys. So let us start. Again, padhoge to badhoge. Okay. So let's start. So guys, see this circuit now. See this circuit. You will see there is a cell of 5 volt. This is internal resistance. When we write 1 ohm, 2 ohm, any ohm resistance ka value near the cell, that is internal resistance, connected to an ammeter. This is ammeter. Ammeter is used to find the magnitude of current flowing in the circuit. Then there are resistor connected of 2 ohm and another 3 ohm and 6 ohm. These resistors are connected in parallel in the circuit. So this is the circuit, the key over here. Okay, the current is flowing from positive to negative. Current is flowing. So let us see guys what they are asking in this question. The first, they are telling you to find the total resistance of the circuit. In this circuit, we have to find the total resistance. It is quite similar for you, this question that you can solve this 2 ohm and next this 3 ohm and 6 ohm. Easily you can solve this guys. Okay, na? But what about this ohm? There is also one more resistor over here, that is 1 ohm. That is the internal resistance. So if I want to simplify this, I will simplify like this. I will remove battery and key, everything. I'll just make a circuit like this, simplify this circuit. So this becomes 2 ohm, this is 3 ohm, 6 ohm, and internal resistance, that is 1 ohm. We don't take, usually it becomes easy. So how to solve this? We have to find the total circuit of resistance of the circuit. So first we'll find the loop. We'll solve the loop. What is loop? A closed path. Can you see this is a loop? We'll solve this. So now you will see 3 ohm, 6 ohm both are in parallel. So there is a formula that Rp is R1 into R2 multiplication upon addition. So this becomes 3 into 6 upon 3 plus 6, that is 18 upon 9. So we get the answer as 2 ohm. Are you getting what is happening guys? We are solving this parallel circuit, that is 3 ohm and 6 ohm. Okay? To solve this, we have to solve this first a loop, that is the closed path. So we have solved this. Now the circuit becomes like this guys. See, now the circuit becomes like this. 1, 2, 3. Why like this? Because once you solve this parallel circuit, it will become series with the others. So this is already 2 ohm, this is 1 ohm. So parallel will become series with the others once you solve this with the value of 2 ohm. Right? Now you guys know formula for series. So series ka formula is R1 plus R2 plus R3, that is we'll add all the 3 resistance, that is 2 plus 2 plus 1, so it become 2 plus 2, 4, 4 plus 1, 5. Okay, na? So we got a resistor ka value, that is 5 ohm, that is basically the total resistance of the circuit. Understood guys? Easy. So we are finding the total resistance of the circuit by this simple method. We got 5 ohm. So I can write as the total resistance. Okay, you can solve this. You can see, you can pause it and you can check and you can write it. Okay. So we got total resistance. First answer guys as 5 ohm. We'll write the answer over here. We got total resistance as 5 ohm. Okay, simple. Second, total current flowing in a circuit or reading of ammeter. Reading of ammeter is basically, ammeter gives you the magnitude of current flowing in a circuit. That is nothing but the total current. Guys, we have to find the total current. Simple. Venkatesh Iyer, V equal to IR. We are finding total current. We should know the total voltage, that is 5 volt. Right? We got the total resistance also, that is 5 ohm. We need to find I. Simple. So I will be 1 ohm. This is the total current flowing in the circuit, that is 5 ohm. है So first we got resistance का value total, that is 5 ohm. Now we got total current, that is 1 ohm. Easy guys, easy. Okay, directly, because see, this is total matlab we have to take the whole circuit ka voltage and resistance. We got the resistance, we know the voltage 5 volt, we got the current flowing in the circuit. Done. Next, third terminal voltage across 2 ohm and 3 ohm. Guys, terminal voltage. What is terminal voltage? The voltage that we get near the cell is basically called as the EMF. 5 volt is termed as the EMF. That is the maximum voltage. Now when we connect resistors, guys, we will get voltage over here. This voltage ka value will be decreasing. Okay? For example, they are asking terminal voltage across 2 ohm and 3 ohm. 2 ohm and 3 ohm. We need to find voltage over here. Simply, there is a trick. You should understand the trick. Wherever you are seeing the resistor, my suggestion will be find the V. That is Venkatesh Iyer. Everywhere. So here V will be I into R. What is I? I is 1. And current is flowing over here. Kitna current? That is 1 ampere. Current is flowing, that is 1 ampere over here. Same over here, 1 ampere. R is 2 ohm. So 2 into 1, 2 volt. Easy. Easy. We can also find V over here. That is I into R, small r. What is I over here? I is same, that is 1 ampere. Why 1? Both are in series. Okay. What is R? R is 1. It becomes 1 into 1 volt. This is V. We can also find V over here. See, we got R 3 and 6. So if we find the total resistance over here, that is 3 into 6 upon 3 plus 6. So we got 2 ohm as answer. So Venkatesh Iyer, we will take I as 1 ampere. And as I said, R, we got 2 ampere by solving this loop, parallel wala. 3 into 6 upon 3 plus 6. We will get 18 upon 9, that is 2 ohm. That is 2 ohm. So 2 volt. So we are getting, guys, 2 volt. Are you getting? This is a trick. We have to find V in all the resistors. They both are together, like they are parallel. We can find voltage will be same in parallel circuit. So here it will be 2 volt, in 3, 6 also you will get 2 volt, because in parallel voltage is always same. Are you getting? This V is called as voltage drop. Always when we are finding V ka value, that is voltage, in the internal resistance, it is called as voltage drop. Are you getting? So they are asking terminal voltage across 2 ohm and 3 ohm. We got the value, guys, for third. That is terminal voltage across 2 ohm is basically 2 volt. And voltage, terminal voltage across 3 ohm is again 2 volt. Are you getting? We got both the answers. Next, we did this 3. Fourth, we got the fourth one also, guys. Potential drop across 1 ohm. As I said, we have to find V ka value in all the resistors present. So, but they are asking voltage drop. So what is voltage drop over here? V. Small v. We got 1 volt. So we got the fourth answer. That's voltage drop across 1 ohm. Then small v. Small v, that is 1 volt. And simple, guys. I add all the 3. 2 plus 2 plus 1. 5 volt. This is 5 volt. Are you getting? So in this circuit, voltage is divided over here. If we add all the three voltage, we'll get the 5 volt. Are you getting? So easy. We got the voltage drop. Voltage drop is always towards the internal resistance, guys. Okay, it's always towards the internal resistance. Next, fifth one, potential difference. Remember this. Very important. Students make mistakes in this part, guys. Potential difference across the cell. Across the cell ka matlab, guys, understand, we have to add the potential apart from internal resistance. This voltage drop chhod ke remove this cell. Cell ka voltage nikal do. We are getting this and this, both the voltage. Add both of them. You will get potential difference across the cell. They are telling across the cell. Remove this. Removing this, we get. So guys, fifth का answer अगर potential drop across the cell, potential difference across the cell will be, remove this voltage, cell का voltage कभी भी निकाल दो internal resistance 2 plus 2, तो answer is 4 volt. Easy done. ठीक है? So potential difference across the cell. So cell का मतलब ये छोड़ के बाकी का voltage को add कर दो. You get the answer. And last guys, sixth one. Sixth, they are asking the current flowing through 2 ohm, 3 ohm and 6 ohm resistor. 2 ohm, 3 ohm and 6 ohm. It's easy. See, current flowing through 2 ohm will be same. This is 1 ampere. There is no other path. This is only the same path. And there is no junction over here. So the current flowing to 2 ohm will be 1 ampere. So current flowing through 2 ohm is 1 ampere. Same current. And now 3 ohm and 6 ohm. Now guys, this 1 ampere current will get divided over here. And this is a junction. This is junction point. A point pe current will be divided. So how can we find 3 ohm, 6 ohm mein current? Easy. Using Venkatesh IR. So current in 3 ohm will be, we know that Venkatesh is IR. So I will be V upon R. And in 3 ohm. So 3 ohm में V कितना है? 2 volt. R कितना है? You know 3. 2 by 3. 0.6 mm. Ampere. Same current in 5 ohm or 6 ohm. How can you find current in 6 ohm? Same guys. I is V upon R. But in 6 ohm. So V is same 2 volt. R is 6. 2 upon 6. 1 upon 3. Basically it is 0.33 ampere. Are you getting? Add both of them, you will get 1 ampere only. So add, so you will see here the current is in 3 ohm, the current is 0.67 ampere. Here the current is 0.33 ampere. So add both of them, you will get as 1 ampere. You will get as 1 ampere. Understood? Understood. So this type of question they will ask you. So I will suggest you to write all the numericals over, solve all the numericals from exercise 8B using this technique. It will be easy for you. Okay, done. Thank you.